Hello guys, and welcome to another Multiple Apps Workflow Series tutorial with me, Eldrin from Logic's Lumiere. Today we're going to be doing another production pipeline series, and I know I said in the last tutorial that one was the last one, but I figured a Houdini to C4D workflow kind of sort of tutorial, even if it included C4DtoA, wasn't really necessarily a C4DtoA technical thing. It's more of a using two programs together and using a helper utility in between to kind of sort of use assets from one to another. Now, a while ago, I did mention OpenVDB alongside Volumetics, and at the time when I mentioned it, there weren't too many tools, especially in C4D, to allow you to really use OpenVDB in your production pipelines if you were using Cinema 4D. In Maya, OpenVDB is a little bit of a weird thing too. They have Arnold as well, and so they have the ability to load volumes via this technique as well. And they've had Arnold for a while, of course, so they've had that capability for a while. Some of Maya's other tools use different workflows like Field 3D and other various volumetric caching techniques to do volumetrics. OpenVDB was initially created by DreamWorks as a method of allowing them to do big productions while being able to save hard drive space and have a grid-esque type of file system that sparsely saved their volumetrics in a way that made it very fast to load, very efficient to have on hard drives, and pretty much very easy to handle. Houdini being the way that it is, I've found that they're not afraid to really just revamp their software completely and kind of sort of screw people a little bit in cross-compatibility with older versions of their software. They're kind of bleeding edge like that, and so they include a lot of different things that a lot of other software companies take a long time to kind of sort of incorporate into their programs. Particularly Maxon is more of a stability type of a company where they like to sit on their hands a lot and wait for a while to kind of sort of get things in there. Luckily for most Maxon users, usually third parties step in and create a lot of plugins for Cinema 4D, and because Cinema 4D is really stable at its core, kind of sort of, that kind of sort of works out for them. RenderMan supports VDB. Arnold obviously supports VDB. RealFlow heavily uses VDB in various different ways to allow it to manage fluids really nicely. And all these renderers here use OpenVDB in quite a few interesting ways. Houdini uses it for a lot more things than just volumetrics. It can be used to convert geometry into a voxelized cloud very fast. And that allows you to do various things like turn two pieces of geometry into basically VDB and then use meshing to like basically bring them back together. So it's like a super advanced Boolean type of thing that you can do with Houdini behind the scenes. And Houdini uses a lot of its tools, use OpenVDB behind the scenes to accelerate a lot of things that other programs have a lot slower algorithms for. Houdini itself is a node-based procedural modeling program. Everything in Houdini, everything from modeling something to creating a character, everything is procedural. Everything can basically be broken down into components. There's no like hitting C to make a polygon editable, and then the procedural nature of that polygon is destroyed, like in Houdini, Cinema 4D. In Houdini, you delete something and it creates a delete node, and then you can easily go back up the chain and go back to the original object, and then you can create a whole nother branch from that object before it was deleted and use that to do something else down the line to calculate stuff. So this makes this program extremely, one, complex, and two, also extremely powerful for people who are technical directors or people who just need something a little bit more advanced. I kind of liken it to it's like a digital content creation app that allows you to create plugins for other digital content creation apps, really. With Houdini engine in Cinema 4D now incorporated, and it's going to be completely incorporated in R17, which is going to be released sometime in September or later this month, give or take. You can basically take these black box kind of sort of node networks that you create in Houdini, and you can expose parameters from them and use them in Cinema 4D as a kind of sort of plug-in interface, where you can just plug in a piece of geometry in Cinema 4D and have Houdini do some really advanced stuff to it and spit the operation right back out to Cinema 4D to use in the pipeline. You can even do things like set up a volumetric simulation in here. In Cinema 4D, you could provide a animated asset, animated sphere, deforming sphere, particles from thinking particles, anything. Have Houdini operate on it and spit out some flames in an OpenVDB sequence to your hard drive, and then render that with Arnold. So, pretty incredible stuff. Thanasis, a C4D evangelist, has done quite a few tutorials. If you look him up, he's done on the Maxon channel, he's done quite a few tutorials on the Houdini engine and some of its more advanced capabilities. I'm not a incredible expert in Houdini. I'm still kind of sort of learning, but I know enough to really get around in here and use it, at least for some of its major strengths, which is its particle systems and its volumetrics. All right, so getting into the tutorial here, what we're going to do is first I'll just go over a few quick navigation things real quick for you so you know what I'm kind of sort of doing. Alt left click, Alt middle click, and Alt right click, same as every single other 3D program for the most part that I use here at Logitech Lumiere. Most programs follow the Maya standard because Maya is kind of the industry standard and the industry darling for a lot of things still. So that's the basic navigation out of the way. Here you have your node editor, and so if I go ahead and control and click on this sphere to go ahead and not have it ask me for, you know, drawing the sphere on the plane and clicking to finish and stuff like that, it'll automatically create a sphere object here. And right now I'm basically in object mode, and so Houdini has a couple of networks that it uses to do various different things. The output network, for instance, is used for a network of rendering nodes, so that's where you would do your shading. The object or surface operators are stored in this area here. The sphere itself, if you double click on it, opens up into another network. This is basically a surface operator network for the sphere, and in here you can do all sorts of cool stuff like turn this into a volume, add a pyro simulation to it, use its surface to generate particles. For instance, I can click on this bottom tab here, I can hit tab, I can go ahead and type in scatter, and the scatter node basically creates points on a surface. And so in Houdini, the only difference between regular vertices and particles is basically the attributes, and it's kind of an important thing in Houdini, concept in Houdini, that every single object that you create in here has attributes, and those attributes determine how these different shelf tools basically will react with that object. So adding attributes like density and heat to these particles, basically using some nodes here in Houdini, will allow these particles to basically be used by the volumetric system as a driver for flame. So you could literally, using some tools in Houdini, paint some particles anywhere on the sphere and have flame only emit from those, because only those particles have the attributes required to actually emit flame. So, like I said, this becomes extremely advanced and extremely powerful as you get more and more into how the different things kind of sort of work. And then, you know, you can keep adding nodes in here basically, and you create a node graph, and that affects your object over here. So none of that pushing and pulling that you're typically used to in Maya, none of that, you know, I'm going to make this editable and I'm going to go into some polygon tools here and try to push and pull polygons. It doesn't quite work that way. You would have to create some sort of edit node here to start, and then it would expose, the node would expose tools for you to actually be able to push and pull and manipulate polygons. Or you could use like an extrude node here and extrude that way. Use a bevel node, extrude that way, different things like that. All right, so anyway, let's go ahead and delete this object. And that's another kind of interesting concept. Most of these objects in here aren't really actually, this is not really actually a sphere, it's just a container for a surface operator network. So this sphere object could technically contain another piece of geometry entirely. I could go ahead and create like a cube or a box, I think is what they call it in here. Now, even though this says that it's called sphere object, inside this surface operator network, there is a box in there. So it's not really a sphere at all. So that's kind of crazy. But anyway, let's go ahead and create a VDB real quick. So here on our shelf up here, we can go to our Pyro FX, and we can go ahead and drop down a quick sphere. And with that sphere selected, we can go ahead and hit flames. And Houdini's going to go ahead and calculate and quickly create that network. And basically what Houdini does is behind the scenes, it runs a Python script and it creates a network of nodes for us. So this is a smart digital asset that the Houdini team themselves have created. It's something that you could easily yourself create if you understood how the nodes were connected together. And they basically packaged it all together using some basic Houdini nodes, no special kind of sort of crazy stuff. They might have used a little bit of Python code here and there, but for the most part, this is all built right directly into Houdini, the stuff that they use to create this. And in fact, you can go and double click on this Pyro solver node, and you'll see that they've got this really huge network here of just standard basic nodes that define how this flame works. And they're all grayed out because this is a digital asset, and by default it's locked down so that you can't really edit it. But you can easily tell it to be unlocked, and you can come in here and you can change it and learn from it. There are a bunch of nodes that define how the Pyro solver works. The source fuel defines where the source fuel comes from. So the sphere object itself has some nodes added to it. They've basically taken the sphere and they've created a fluid source node, which has defined how the sphere gets converted into a volume. And then they went ahead and merged real quick, and then they've output a null, and this null is basically referenced in the PyroSim network, which is a DOP network or a dynamic operators network. This is where all dynamics type stuff happens. So once again, everything in Houdini is networks. And then in here, they pull in the output fuel from the SOP network. They go ahead and merge it in, and they plug that into the Pyro solver right here, into one of the Pyro solver's inputs. Plug in the basic Pyro simulation into another input. Houdini has the ability to automatically resize volumes. So unlike Turbulence FD, in Houdini you can set up a node in such a way that as the simulation expands, if I hit play, the volume automatically expands. And what's really great about Houdini also is, something like this, you would kind of start to get a little scared in C4D, because it's like, okay, well, if I have to have a volume this big, now I got to deal with memory issues and like whether or not, this volume is too big and different things like that. Here in Houdini, it's like really efficient at handling large data sets, extremely large data sets. And I haven't ran into too many issues with how big my flame simulations have gotten, really. I can let this play and I can kind of sort of let this volume keep expanding. And I don't really run into a significant amount of issues as far as playback speed. I mean, see, this is relatively moving around in the viewport at a good clip. And the simulation, the smart object basically has generated a caching mechanism as well behind the scenes. So this is caching on your hard drive really nicely. So just that quick, you get a nice flame simulation. You can come into this node, change a few different things like the division size will change the resolution of the flame, give you much more detailed, crisper flame. The pyro solver itself is going to allow you to do different things like control the turbulence of the flame, get more wispy flames or the disturbance, shredding, create more detail in the flame. You can mess with the initial SOP network itself. You could bring an alembic in here and use that to generate the flames. And if you were to do that in Cinema 4D, you could probably create a better shape to initially control, you know, how the flames are going to come out, and then create a volume out of that and do all that kind of good stuff. So that's great. This last little network here, the pyro import, this is where all the fields from the VDB or from the flame simulation come into play. So this import pyro fields here, this purple one, this is the one that actually has all of the fields that were generated by the flame simulation, whereas the other one only has a few fields related to being able to actually render this in the viewport. So if we go back to the pyro sim real quick, and we go to the pyro, you can see all these fields here. These fields control how this flame actually does what it does. And you know, we've got a lot of different fields here, basically. And so these get pulled in here. And so if we want to actually export this out, what we need to do is we need to go ahead and click on the bottom little tab here. That's going to drag out a line. We can hit tab and we can do a convert VDB. And what it's going to do is convert our fields into VDB. And we want to convert to VDB. We're using OpenVDB, and all the rest of this is okay. And so we can come in here now and we can go ahead and look at all our fields, and we can grab whatever we want to grab to go ahead and render this in C4DtoA. So probably want to grab heat. That's the visualization for the actual flames themselves. We'll probably want to grab density. That's the visualization for the smoke. And we'll probably want to grab the velocities because that's going to allow us to do some interesting things in C4D as well. And then the other fields I usually leave alone. I don't really grab temperature or fuel. They're not really required. And the more fields you grab, the bigger your OpenVDB file is going to be. So you want to grab as few as possible, just what you need to go ahead and actually shade and render in C4DtoA. So we're going to go ahead and click on this bottom tab of this node here, and we're going to do one more node. The node that we want to do is a file node. And what the file node does is it's kind of like the end of a network here in here in Houdini. So a nuke, you might be, if you're familiar with nuke, you might be used to a node called the write node, and that usually ends your tree in nuke, and that allows you to actually write your files out to the hard drive so you can manipulate them in After Effects or Premiere Pro, or you can go in Media Encoder and encode them together into a file. This is similar, but for geometry and stuff. So what we want to do is change the mode to write files, and then here we can go ahead and actually select a document that we want to write to. But before that, let's go into our directory structure here, and we're going to go and grab Testa2's folder here, and we're going to go ahead and grab our shot character folder. If you remember from the last tutorial, I talked about creating an asset template and just having a quick way to basically start a new project. So what we're going to do in here is we're going to go ahead and do a Control-Shift-N keyboard shortcut to create a new folder here in Windows Explorer. Command-Shift-N on the Mac if you're in Finder will also create a new folder. And what we're going to do is we're going to call this volume test real quick. And then what we're going to do is we're just going to drag in all our basic folders here in there. Once again, like I mentioned, I went behind the scenes myself and I've created like an Arnold base. And this already has a 4K preset and a 720p preset. And it's already set to 24 frames per second for me. And everything is kind of sort of set up the way I want it. I've also got some base layers just in case I'm working with a character and that kind of sort of good stuff. I've also got a VDB folder here which is empty, that I can put my VDBs into. So I'm kind of sort of set. And then I do not have a Houdini folder yet. So what I'm going to do is update my template here with a Houdini folder so that I have a place to put my Houdini files. I must have overlooked that one. Alright, cool. So now we've got a Houdini folder in here as well to put our Houdini files in. So let's go ahead and save this project out to our H drive documents, testa2 and volume test and Houdini, and we'll call this volume test for lack of a better name to call it. Accept. All right. And so with that, what we'll do here is we'll go into our file selector again. We'll go to where the hip file is. And so that's going to be the Houdini folder. And if we go one step up, we can go back into our main asset template here. We can go to VDB, and we can go ahead and call this file test.vdb and accept. And there we go. Now, Houdini works quite similar to Nuke or C4DtoA in the sense that by default, it's just going to go ahead and basically write out the same file multiple times, and it's going to completely overwrite it every single time instead of giving you a sequence number. So if you want a sequence number out of this this file, you're going to need to do something special in Houdini. And Houdini is a little bit different than Nuke or After Effects or C4DtoA in the way that it allows you to write sequences out. It doesn't use the pound signs like most other programs. It uses a scripted notation, a variable of sorts, to manage that. Now, if you look here, you can kind of sort of get a little bit of a hint of how that actually works. So here, the import field is actually importing in from the hip, and from this variable, it's basically importing every single frame based on the frame that I currently have selected. So this variable becomes 82, and it is importing in that file, and it's using the fields from that particular file to go ahead and pipe into the convert VDB, which then gets piped into the file. So this variable here is the important factor here. So basically my file will be called test underscore, and then it's not going to write out any special number. But if I add a $F here, and then if I add a 3 to it, what's going to happen is it's going to write out the frame, and then it's going to write out 3 extra digits onto the end of that frame, which is going to give me a 001, 002, 003, so forth and so on. If I were to just put $F here, it would just write out just 1, 2, 3, and I wouldn't get that really nice 00 at the end. That makes everything look kind of sort of organized. So there you go. That's your variable, and that's going to write out your numbers. From there, all we got to do is just play through the simulation with this node selected. So basically, if we set this node as the viewable node here, you'll notice your simulation changes here, and that's because you're not visualizing the actual simulation anymore. You're visualizing like the fields, and the fields don't really have the correct simulation look to them, whereas this visualization does. And that's just a fact of the nature. Be rest assured that all the fields that you told it to export out, all that flame and all that heat is going to get exported out into this file, even though it looks this way over here. So all we have to do is just play through the simulation. I'm just going to go ahead and write those files out for us. And so we'll write out a few, maybe up to 92. Let's go onto our hard drive and let's see what we've got. So here in volume test, we can go to VDB, and you'll notice here that, yes, it did indeed write those VDBs out. It also wrote that first VDB out because when we had write files set up initially, it just went ahead and it wrote that out because we hadn't actually changed our configuration yet. We can delete that file, we don't need it. And one thing you'll notice here right away, at least with this resolution of this default simulation, these VDBs aren't really that big, surprisingly. You know, so it's a very efficient, very, very, very strong format. It's the reason why DreamWorks uses it and created it. It's the reason why a lot of other people use it and create it as well. It's a very efficient volumetric format, even when you have extremely complex simulations. All right, so here in C4D, we can go ahead and open up our Arnold base file here. So we can go to Testa. We actually go to Documents here real quick. Then go to Testa. Then go to VO for volume test, and then go into C4D. And then what we're going to want to do is probably rename our Arnold base to what our project is going to really be called. So I'm going to call this volume test. And then I'm going to go ahead and open this up. And I've already got, like I said, a few layers set up already for myself. Got my preset for 4K, 2160p, and I got my preset for 720p. I'm going to go ahead and go back to 720 so that my IPR isn't super duper slow. Already set to 24 frames per second there, and if I hit Control D, the project itself is already set to 24 frames per second here in the master project settings. All right, so what we're going to do is create an Arnold sky real quick for some just quick lighting. And we're going to go ahead and use the Arnold volume now. And so what the Arnold volume does is, by default, it's set to OpenVDB. You can create a box or a basic sphere and use that for volumetrics as well with this. But most of the time you'll be using OpenVDB. And OpenVDB files can't be generated in C4D. So you go to a different program that can generate them, and you'll basically import them in. By default, the grids that it imports are density, velocity x, velocity y, and velocity z. We can go ahead and tell it to import in the heat field as well, since we exported that, and you just put a space between the fields, and it'll go ahead and import those in. And then we can go to our file path, and we can go ahead and import that in. So let's go to Testa2, and let's go to volume test, and let's go to VDB. And let's go ahead and import in the first VDB. And by default, Arnold will automatically put in the pound signs for you. And it also lets you know here what your available grids are, so that you can easily type them in here if you wanted to, which is really awesome. All right, so as you can see, the volume pops in and it's expanding. And if we go ahead and render this, we will see that we get just this big, huge, nasty cube with a volume in it. Now, why is this? Well, the reason why this is rendering this way and we're not really getting any flame, and this really threw me off about OpenVDB for a long time in Arnold when I first started, because by default, Arnold doesn't know how to really send rays through this field. We're not really telling it in any sort of way how to kind of sort of read any of the grids that are in here. It doesn't know what parameters to use to kind of sort of put those together. So in order for you to actually really see what your volume really looks like and get all that detail, you have to have a Arnold shader attached to this. And the shader that you're going to use for this is the volume collector. The volume collector shader, if we go ahead and apply it to our volume, allows you to basically shade volumes. It tells Arnold how to go ahead and send rays through there and define this volume. So if we go into the volume collector shader and we go under the scattering source, we can go ahead and say, instead of parameter, we want you to use a channel. And the channel that we want you to use for scattering would be density. So for scattering, we want you to go ahead and use the smoke channel in VDB, which would be the density channel, to go ahead and actually render out that sampling. And so it goes ahead and does that, but we're still not seeing, our volume looking good. And the other reason for that is the scattering defines how the rays are going to kind of sort of scatter in that volume and spit back out. So the photons go in there, they hit debris, and then they come back out, and we see what we see. But the attenuation defines how far into the volume the rays go before they hit particles and then come back out. And so right now the attenuation source is still set to a parameter. And so if we set it to the scattering, now we'll see our smoke. And there we go. And so that is the smoke field in our volumetrics coming through. Now, what I would like to do is, so we can see this a little bit better, I'm going to go ahead and go into this Arnold sky, go into my background, click on the little disclosure triangle right here, and I'm going to go into texture. I'm going to go ahead and load up a different texture. And I'm going to use a texture from this new Baby Jam IP that we're working on. And that's going to give us some nice lighting, a little bit better lighting to see our volumetrics in. And so we can get a better color out of that. And so we can control the scattering color. I'm just going to define the color of how the light scatters from that volume. And we can darken it and brighten it and do various different things to it. Color it red. Or we can leave it purely at white. Scattering intensity is going to allow the volume to scatter a lot more, and basically more of that color is going to come through, or scatter a lot less. A lot less of that scattering color is going to really come through. The attenuation defines what light rays travel through the volume. So if we were to say make the attenuation color red, then you'll notice that the color of the volume is going to go kind of sort of in its polar opposite. Basically we're saying that the red rays aren't going to really go that far into the volume. They're going to get cut sooner. So the blue and the green rays are able to actually travel more out of it. And we can control that intensity of that as well. Using extinction, we can get a completely different result out of that. I find extinction is a little bit more stronger of an effect, and if you're looking for that kind of sort of look, it's a really great way to go. And then vice versa, if we go the way of blue, we should see a lot more red coming out of our volume. Alright, so we'll put that back at white and let the basic color come through. Alright, so that leaves us with emission. So emission is going to allow a channel or a parameter or something like that to basically control the brightness of the volume. So emission, heat is an emissive source of light from a volume, and so using emission we can basically get that flame. So using our channel as a source, we can go ahead and use the heat channel as the source. And the reason why I know it's called the heat channel is because I know that that's the grid I put in here, and this is the available grids that it gave me. So I know from messing with Houdini and knowing how I created this flame initially, I know that heat is what I want to use as my emission source. That's kind of how I got that. And then the emission intensity, of course, you can intensify that heat. You can change the emission color as well to whatever you want to change it to. So we can use a golden orange here, and now we're going to get this golden orange for our heat. But a better way of defining the emission color, of course, is to go into the network editor, and in here we can get kind of sort of hardcore with how we actually control this volume collector shader. We have all the same properties here as we had in the attribute manager there, but we can go ahead and add a node to this. And so there is a node available in the AL shaders called black body. There's also a utility node defined by Solid Angle themselves, also called black body. But I like using AL black body. So we can go ahead and plug AL black body into the emission color. And so what the AL black body shader does is it does the same thing that the turbulence FD shader kind of sort of does. Depending upon the temperature of the flame, based on the heat grid itself and what temperature it's exposing, basically using our temperature, we can basically control how hot this flame actually ends up being just by messing with the temperature slider. And then we can control the strength of that as well. And in the advanced, we can control the physical intensity, the physical exposure, and different things like that if you want to get a little bit more advanced with it. But the black body shader basically gives you a pretty accurate and easy to control result for fire. And so, once again, because we exported that volume out of Houdini as well, we've got a fully animated flame here. And it looks absolutely gorgeous. Alrighty, and so that is it, guys. That's OpenVDB in a nutshell, how to bring volumetrics in. If we go ahead and do one more example here real quick, discard and new. Go ahead and this works pretty much with any volumetrics in Houdini. So we can go into Cloud FX. And we can go ahead and basically, let's go to the create panel to create a quick box, drop into the scene. With it selected, we can go to the Cloud FX and we can go ahead and create a cloud rig. And that's going to go ahead and VDB and create a cloud for us. How lovely is that? And then under the cloud here, we can go ahead and once again, on the cloud light, go ahead and hit tab, do a convert to VDB, select VDB, select which field we want to send out. So we want to send out the density in this case, and I guess we can send out the CE, CX, and CY as the velocity fields. Though for a cloud, we're not going to really necessarily need those. And then, once again, we put a file node in there and write out a file. Tab, file, file node, and that'll be that. Under the cloud noise, we can go ahead and increase the amplitude of the noise, make the cloud more noisy, like so. Under the cloud itself, we can create scatter shapes, and go ahead and change the source itself so that it has more shapes to it. So if we go ahead and view the cloud noise, we can see what that looks like, or view the cloud itself. We can see how the original source looks before we add noise to it. And here's the noise. Come in here to the cloud light, we can see how it looks just with the light, and then coming down here to the file finally, well, that's not going to really show us very much because once again the file doesn't really show the fields very nicely like the final light node does. So this is the node that you're really going to look at to see what your cloud's going to look like in Arnold, relatively speaking. Once again, the way you shade it in Arnold changes how it looks, and also you've got the lights there as well that are going to change how it's lit. But yeah, you export that file out the same way you export out the flame. This time, of course, you probably won't use the $F3. Probably just use just the file as is. Export that out and you're good to go. So there's a whole bunch of different volumetric objects here in Houdini. And this is probably the best program to go ahead and generate out that kind of sort of material. And so in the next one, I'm going to go ahead and cover the new Arnold 1.0.5.0 material conversion stuff. They have released a new version just yesterday that now has the ability for you to be able to convert C4D materials to Arnold materials. And for that matter, it's really cool because you don't even have to convert them actually. You can use C4D standard materials by themselves, and Arnold will render those materials out. Behind the scenes, it automatically converts them into Arnold materials without you doing anything. But you can always convert them yourself and then have that additional power to be able to add more nodes to it and use the node graph. So, look forward to that one, and thanks for watching, guys. Take care.